All right, hopefully you're sticking out with me. This should be FRQ 3, then the third one that I'm doing here, because there's a lot of different ways they could be, but it's not too bad. So if you've watched the other two, I'm going to go through this one rather quickly. This time we're looking at a ball's distance from a wall in this question. So a tether ball gets hit and spins around the pole 3 times in 1 second. Here we see our period. It's going to happen 3 times in 1 second, so this is going to be 1/3 as the period of our function, which makes this question sometimes a little bit tougher, but don't worry, fractions are not supposed to be too hard. Then it says the pole is 10 feet from the wall, we see here in the diagram, and the ball is 2 feet from the pole, always, right? It's always going to be 2 feet from the pole. So that means at the farthest distance from the wall, this would be 12 total feet. That's going to be our maximum for the question. And then if the ball happens to be over here, 2 feet now that way, that would be then 8 feet from the wall. And the good news for us is right here. At t equals 0, the ball is furthest from the wall. So when we're furthest, we like that. This is perfect. I could just go ahead and throw a 0 right there for f, because that's my first maximum, and that's at when I'm furthest from there. Remember, p is the end of the period, so 0 plus 1/3 would just be 1/3. And now we're just playing the game of halves. J is always going to be half of 1/3, which is just 1/6. You multiply the denominator by 2. Then G is always going to be half of that, so denominator times 2 again is 1/12. And then the trick here in this question is to go from G to K, just add 2 to your numerator. The only problem, though, I'll work it out here on the side, is that would be 3/12. Got to make sure you simplify that to 1/4 for our question. So this would be 1/4 here on that interval. And there you have all your times. Fractions tend to make things harder, but here it's not too bad. We have our maximum right here at 12. This is our other maximum as well, which will simply be 12. We already found our minimum. Remember, minimum is J, so that'll be right here, 8. And then for this question, wherever the pole was, that is our center line, our middle. So that makes this one easy, which is 10 and 10 for G and K. But you could have also just added 12 plus 8 and divided it by 2. So real quick and easy there. Even though we got some fractions this time, we easily figured out our coordinates. If you watch the other 3 videos, then you'll remember how to find your A, B, C, and D. A here is going to be that maximum 12 minus the minimum divided by 2. So that would be 4/2, which equals 2. And remember that from the question. That's how far the ball is from the pole. So that is another way sometimes you can find A. We should know D already, but I'll show you the math again here. If we add those and divide by 2, that would be 20/2, which is 10. That's from G and K. And the only thing here that could be a little tricky is your B. It's 2 pi divided by the period 1/3. Ooh, scary. Fraction in a fraction. Don't you worry. Here you're just going to do 2 pi times the reciprocal of your denominator, which is just 3. And that'll give you 6 pi for B. So the fraction, if you switch it, makes it relatively simple. And then let's take a look at sine. Remember, sine always goes with K. I'll highlight it again here for you. Here's your first sine period. So if you're doing your phase shift to find C, you just get the opposite of K. We're 1/4 unit to the right. So this will be negative 1/4 as my phase shift there. And then for cosine, cosine always goes with F. Because based off of my graphs, using the points that I know, there's your first cosine curve, sorry. And that is phase shifted. Oh, right there, it's at 0. It's on the y-axis, which makes this pretty easy. This would have been 0 if it was a cosine question. So pay attention to if it says sine or cosine there. You could potentially mess up your C. And then here, I didn't put the multiple choice, but hopefully we remember what that is. From K to P, we're looking right here. Our graph, our values from K to P is going from 10 to 12. So that is positive, and from 10 to 12, it is increasing. So that would be option A, if you remember, will be positive and increasing. And then finally, same 2 points. So on the interval, T1 to T2, the rate of change is, and let's see, K to P is concave down. So that is going to be decreasing. And then there is because the graph is concave down. And there you have it, folks. If you watched all 3 of those, hopefully you got a better understanding of FRQ 3.